Hello, today I'm looking at M3 International A-Level and this is January 2016, question 7. So I have a particle of mass m is attached to one end of a light rod of length L. The other end of the rod is attached to a fixed point O. The rod can turn freely in a vertical plane about a horizontal axis through O. The particle is projected with speed u from point A, where OA makes an angle of alpha with the upward vertical through O, as shown in figure 4. The particle moves in complete vertical circles. Given that cos alpha is 4/5, show that u is greater than this, and this is for 4 marks. And then as the rod rotates, the least tension is T, the greatest tension is 40, show that u is equal to this value. Okay, so we will begin by looking at the energy, because I know for this to do a complete circle, then there needs to be enough energy for this particle to end up going around here and then going fast enough so that it will be able to reach this point here. So if I look at the kinetic energy when it's at A, then I need that to be equal to the kinetic energy at the top plus the gravitational potential energy at the top. And so basically I'm assuming that when it's at A, there is no gravitational potential energy. So the kinetic energy at A is half times the mass, and the mass was m. The velocity was u, so here I have u squared, or the speed was u. And then the kinetic energy at the top will be half m, let's call the speed at the top v, so v squared, plus mass times g times the height. So the difference in height from here to here, well, from here to here it's L, but then I need to take off from here to here. So if I imagine this right angle triangle here, if this is L, this length here is L cos alpha. And so there is my conservation of energy equation. So I can, I'm trying to get an expression for u. So I will divide everything by m and multiply everything by 2. And so I get u squared is v squared plus 2gl minus L cos alpha. But cos alpha, they told me, was 4/5. So I'm doing 5/5 minus 4/5 makes 1/5. So here I end up with 2gl over 5. So now I know that there's that the particle follows a complete vertical circle, and so therefore I know that v will be greater than or equal to 0 at the top. So for complete vertical circles, I know that v will be bigger than or equal to 0 at the top, and so therefore I'm going to get v squared is equal to u squared minus 2gl over 5 will be bigger than or equal to 0. So therefore I get u squared is bigger than or equal to 2gl over 5, and therefore u is going to be bigger than or equal to root 2gl over 5 as required. Okay, so that is for the first 4 marks. Then it says, as the rod rotates, the least tension in T is T, and the greatest tension is 4T. Show that U is equal to this thing. So, well, the least tension is going to happen at the top, and the greatest tension is going to happen at the bottom. So if I look first of all at the bottom, here's O, here's my particle. The mass was m, so the weight is mg. here, this is the greatest tension, so I'll call this 4T, and this will be accelerating towards the centre of the circle. I'm not quite sure what the speed is going to be here, so I'll call it x. So the acceleration will be x squared over the radius, which is L. So writing down Newton's second law for this, I get 4T minus mg is mx squared over L. And so now I need to know what x is. So looking back at my diagram, then x is when the tangential speed when A reaches the bottom, because this was the situation when the particle is at the bottom. So if I look at energy, then I have that the kinetic energy when it's at A, so half times m times u squared, plus the gravitational potential energy that it's got when it's at A, which will be L plus L cos theta, alpha, sorry. So mg times the height, and when the particle comes down here, we'll say it has no gravitational potential energy. So this is the level that we're measuring gravitational potential energy from. And here we said that the speed was, we called the speed x. So the kinetic energy will be half mx squared. Okay, so I'm interested in x squared so that I can pop it in here. So I'll divide everything by m. I'll double everything. And so I get that x squared is u squared plus, and cos alpha was 4/5. So here I've got 5/5 plus 4/5 makes 9/5 times 2. So here I get 18g over 5L. And now I can pop this in for x squared up here. So this was Newton's second law. Let's call this 1. This calls 2. And so I'm doing sub 2 into 1. So I get 4t minus mg equals m over L times x squared, which is this. So I'll end up with 4t is, multiplying this out, okay, so here the L's cancel, and then here I get plus mg, because I added mg to both sides, and now lumping these two things together, I get 4t is mu squared over L plus, here I've got 18/5 plus another 5/5 makes 23 mg over 5. Okay, and that's kind of as neat as I can get it, really. Then I'll look at the particle when it's actually at the top of the circle, and I already have an expression for what the speed was there. At the top of the particle, then I did this work in part A, so I can get that v squared is u squared minus 2gl over 5, this expression here. So at the top, O is here, the particle is here, and so I'll have the force down of the weight plus the tension, which this time is just t, and again it will be accelerating towards the centre of the circle. The velocity at this point we called v, so the acceleration is v squared over the radius, which is still L. So writing down Newton's second law vertically for when it's in this position, I get mg plus t equals mv squared over L, but this time I know that v squared is this thing here. So this gives me that t is m over L times v squared, where v squared is this expression from here, this expression from here, u squared minus 2gl over 5 minus mg. Okay, so I'll call this equation 4. So now I'm going to say that 4 lots of this equals that. Oh, actually, I'll just tidy this up a little bit before we do that. So here I get mu squared over L minus, right, here the L's will cancel, so I'll get minus 2/5 mg minus mg. This is 5/5, so negative 5 subtract 2 is negative 7/5. Okay, so let's call that one 4. Okay, so now I'm going to do 4 lots of equation 4 equals equation 3. Putting these two equations together. So 4 lots of this. So I get 4 lots of mu squared over L minus 4 lots of this. So 28 mg over 5 equals this stuff. Mu squared over L plus 23 mg over 5. So pop in all the mu squareds over L on this side and all the mg's on this side. Here I get 28 plus 23, so I get 51 mg over 5. And so I get for u squared, 51 oh, actually cancel the m's. So I get g, the L ends up here. On the bottom I've got 3 times 5. And in fact I know that 3 goes into 51. 3 will go into 51 17 times. So I end up with u is the square root of 17 gl over 5. And so let's just compare that to what they said it would make. They said this, show that u is this, and phew, they're the same. So that part of the question is worth 11 marks. So you've got 11 plus 4, so there are 15 marks altogether in that question. Okay, there's quite a lot of algebra, but it's all the same work over and over again. Energy resolving, and then you just need to pop it all together. Okay, so I hope you found that solution helpful. Do click like if you liked it, and good luck with your revision.